Welcome back. While bar charts compare categories, the histogram is specifically designed to show the distribution of a single, continuous numerical variable. It allows us to see how frequently different values or ranges of values occur in our dataset. We use the dedicated function plt.hist for this visualization. 1. Preparing continuous data. Unlike previous plots that needed both X and Y arrays, a histogram requires only one continuous array of values. We generate 1,000 random data points that follow a standard normal distribution, meaning most values cluster around 0. This is perfect for illustrating distribution. 2. The role of bins. The core concept of a histogram is the bin. The range of the data is divided into intervals or bins. The height of each bar in the histogram represents the count, the frequency, of data points that fall into that specific bin interval. The number of bins directly controls the shape and detail of the resulting plot. 3. Generating the histogram. We generate the histogram by calling plt.hist and passing our data array. By default, Matplotlib will choose an optimal number of bins, typically 10, for the visualization. We add a color and alpha for better visual appeal. Running this shows the classic bell curve shape of the normal distribution. 4. Customizing the number of bins. If the default setting lacks detail, we can specify the exact number of bins using the bins argument. Setting bins to 50 provides much finer resolution, revealing more minor fluctuations in the data distribution. Choosing the right number of bins is a balance between smoothing out noise and retaining important details. To summarize, histograms are essential for understanding data shape. Our next lecture 37.09, Plotting Subplots. See you there.